The stage of evaluation refers to quantifying how a model performs. So here we're going to spend some time talking about one of the two main cases of supervised learning, which is regression, linear regression. So what we see is on the lower right an illustration of data points, and the best shape that the shape that best describes these points is linear, is the so-called regression line, or best fit regression line. So I'm trying to highlight here in yellow this line. Okay, so the circles are the illustrations of the points, and then there's something else there that we're going to talk in just a minute. But this so-called the outcome of using training the model with a subset of the data and then doing some tuning or testing, ultimately we would like models and algorithms to calculate something. And so in this case, this line is the outcome of a model. So to underscore even further, so this prediction by the model prediction, are precisely what the model computes is this line. And well, more strictly, this line is a set of points, a set of values that define the line. But each of those values along the line is what is they're referred as values that are predicted by the model. So this is the so-called model prediction. So I just want to underscore that when if you are thinking of this as an outcome of these tools, the outcome in this case is the line. We started with the points. The outcome after doing the training, the model training, is the line. So based on this prediction by the model on this line, one can measure the distance to each of the original data points. So there is the notion here of the data point is denoted as y sub I, and the predicted value is denoted here as y hat sub I, and the difference between these two, this difference is some kind of discrepancy, right? So is how that's the idea of measuring. If they are perfectly a perfect match, this difference would be 0, right? And so the fact that this difference is not 0 is reflected here by having distances, vertical distances, that they're a little farther away. Some of them are below or above the model prediction. So there is a reserved name for this, which is called residual. This is sometimes called, this discrepancy could be considered an error. It's also sometimes called residual. So just to even reinforce a little further, so when using these tools, the models are able to make calculations, come back with predictions like this line. The line on its own is not enough. There needs to be a quantification of the performance of that tool, and this is where measuring the distance between the sometimes it's called observed versus predicted, the distance between the data point and the predicted values by the model, that quantification of errors is what will be then used to have some metric of performance. So you could look at this formula here. This index I runs between 1 and n in uppercase, and so this is a way of measuring such discrepancies. The reason you could have other versions of this particular form. For example, you could just consider the absolute value of the difference between y sub I and y hat sub I, and then you could consider the sum of this absolute value of the difference. You could just consider the difference without absolute value. In that case, that's what we were seeing in the previous picture. Some of those values are negative, some of them are positive. That's why you see bars below and above the prediction, the best fit regression line. But by taking the square, you're only dealing with positive quantities. Ultimately, you just would like to work with, ideally, you like a good quantification. A good metric would be whenever those discrepancies are close to zero, where especially when they're being squared. So this idea of dividing by the total size of the total number of data points, the total size of the sample, is a way of aggregating or normalizing this quantification. So besides mean square error, there are other quantifications. There's one called root mean square error. That is also called the mean absolute error. Okay, but one thing that should come to mind is the so-called R square. The R square is a very traditional quantification of is the model well suited to describe this data, and it serves the same purpose about assessing the performance of a tool, in this case a line, to describe the data points.